ridiculous. I'm sorry.
Oh, that's all right.
I see. Well,
Ever since first drawing up my garage, I dreamed of having a large walk-around project table that would do it all. A large surface to spread out parts for projects so I can walk around for easy access, a place where I can safely and comfortably weld, cut, and fabricate, and something aesthetically pleasing that looks finished and hides the inherent messes involved in metal fabrication and other car projects. The first step was to figure out a general vision for what I wanted the end result to be. And then from there, I'd work backward into determining the specifics of how I would actually build that and achieve that end result. I've gotten in the habit of using a 3D modeling tool called SketchUp anytime I want to plan out spaces and objects so that I can ensure that I create an end product that I'm happy with before I invest a bunch of time in it. As I began thinking about it, a few core considerations came to mind that would guide the design. I knew I wanted it to be an island with space to walk around all sides for large projects. It needed to be usable for welding, but I know that the majority of the time I'd be using it for other day-to-day use. It needs to be solid enough that I can hammer on it with objects mounted in the vise and it not have it flinch at all. It needs to be enclosed to have a clean look and not look messy in the garage, but I also need to be able to sit comfortably at it, tuck my legs under so that I can operate a TIG welder foot pedal. Additionally, it should be stable while in position, but also be possible to be moved easily for cleaning or if I decide I want to rearrange the garage at some point. So it needs to be able to roll, because I know this is going to be heavy. And last, it has to be reasonably affordable. Any remotely comparable tables that you can purchase cost thousands of dollars, and they still don't satisfy all of my criteria. There are cheaper options available, but it felt like a major compromise that I would have ended up replacing before too long. Making it affordable all came down to material costs. For a long time I thought, and I had actually planned to build the frame out of wood because of the cost of steel. Ultimately I was able to pull it off in steel, but it required a lot of flexibility in my planning. Instead of drawing up the ideal and then placing an order with a local metal supplier, I created the concept design of what I wanted to end up with, and I kept a close eye on Facebook Marketplace for random deals on steel cutoffs. When I saw something interesting, I quickly sketched out a model of a frame to see if it would work. The first couple times this didn't work out, but eventually I found a lot of 48-inch long cutoffs of 1.5 by 2.5 rectangular tube with a 1/8 wall. I drew up a design, was satisfied with the result, and then went to pick up that steel an hour later. To enclose the table and provide a finished look, I knew I wanted to integrate some 30 by 30 Gladiator wall cabinets that I had around. These would form the front face of the table. These cabinets ultimately shaped the main dimensions of the frame, resulting in a length and height that was nearly ideal for my space. For the sides, I decided I would use flat panels, which would be easy enough to work out the details of later on. After finalizing the plan for the frame, I needed materials for the top. I decided on 1/4-inch mild steel as a compromise of affordability, the fact that I could move it alone without a forklift, and most importantly because it serves well as a multifunction surface for anything including welding. Stainless steel was too expensive, and any thicker mild steel would be too heavy for me to work with. Given the box structure frame I was building to support it, 1/4-inch would be solid enough for this. Many fabrication tables have holes for fixture clamps, but I wanted to keep a solid surface to avoid small objects like wire terminals, bolts, etc. from falling down. While I do plan to use this for welding, that's only one of its occasional uses. And last, I selected a set of load leveling casters. These allow you to lower a foot with a ratcheting arm, which raises the caster off the ground and rests the table's weight on a solid foot that can't move. With that, The design accounted for all of my requirements and it was time to actually build the thing. The first step in building this is measuring and cutting all of the steel frame tubes to size. This is where the 3D model is really helpful. Exploding the model allowed me to quickly create a cut list, which I took into the garage and got to work with the horizontal bandsaw. While the bandsaw makes this nice and clean, it still takes quite a while to make the 40 some odd cuts needed. I chose to miter the corners mostly for aesthetic reasons, but also because I wanted all sides of the frame enclosed, which also makes it simple to attach things like casters, etc. Before we start welding things together, all the steel needs to be cleaned and prepped. Each butt weld joint gets a chamfer with the angle grinder and a flap disc to ensure that the weld gets enough penetration, especially given that I intend to grind any welds flat for a more finished look at the end. After that, a few rounds of wiping the tubes down with acetone have these clean enough to start welding the frame tubes together. The first pieces to weld together are the 3 boxes with mitered corners. These carry the load from the top plate down to the casters. With these tacked together squarely, I'll finish them right away and then grind down the welds flat, because the horizontal frame members that go in between these 3 uprights will attach to them right in that same spot where that mitered weld joint runs. From this point forward, I decided it would be easiest to weld the rest of the frame upside down on top of the 1/4-inch steel plate. I lay out the 3 vertical supports with the upper horizontal members between them to double check that everything's going to fit as designed and there isn't anything I measured incorrectly. After verifying things all look good, I clamped the first vertical support box into place, leaving a 1.5-inch overhang for the top that I designed in previously. This allows for a surface to clamp to into the future. Next, I carefully adjust the position of all of the tubes to ensure that they're square and maintain that same 1.5-inch overhang for the top before clamping them into place to tack. I slowly tack one tube at a time, repeatedly ensuring that the frame is square with each new tube that I tack into place. Right about now, it's starting to feel like playing with grown-up Lego, and it's quite gratifying. I left the steel plate on the pallet I received it on, thinking it would be a nice way to keep it off the nice coated floor. The overhanging edge sagged a bit though, so I had to jack it up to get it square before welding the frame on that side. This is a lesson for next time. Take it off the pallet and find a better flat surface to work on. Before long, all of the main frame members are connected and then fully welded together. Because I chose to use 1/4" steel for the top, and I knew that at some point I would inevitably pound on something heavy on top of this bench, I wanted to use the remaining steel tubes to reinforce that top as much as possible. This also has the major benefit of reducing the resonance of that top plate, which is a consideration with a smaller plate like 1/4". I had already planned for 2 more tubes to be added to the center as bracing, but I noticed that I also had enough steel tube left over to add some additional shorter braces between the center brace and the perimeter. I chose to bias these toward the backside of the table where I knew I would be most often working, because there wasn't enough length in them to have them truly in the center of the table. At this point, it's time to attach the frame to the top. I stitched them together with 1-inch long welds every 8 to 10 inches or so, and things are feeling quite solid. Now that the frame and top are one piece, I can shift it onto a dolly for ease of repositioning. This also allows me to move the table outside to lessen the mess of grinding dust, which was really starting to add up in the garage. After rolling the table to the door opening, I grab the angle grinder with the flap wheel and grind welds. Adding the load leveling casters is a pretty simple affair. Just mark the holes, center punch them to avoid the drill bit from walking, drill the holes, and then tap for M6 by 1.0 bolts. You can now see how the ratcheting mechanism works on these to raise and lower that foot, as I described before. This provides a dual purpose of leveling the table, but also transitioning between mobile and stationary. At the time, I didn't consider how valuable that leveling component would be, but with a graded garage floor, this is really helpful. Despite the structure of the frame being complete, I still need to add mounting provisions for the 2 Gladiator cabinets, the side panels, and the floor. I planned on securing the cabinets around the perimeter of the face, but still decided that I would add in some extra supports to the bottom of the frame that they could sit on. While this isn't really necessary, it does provide a little more bracing for the frame as well, and I have the material, so why not? For the floor, I welded in 1/2-inch square tubing to act as a ledge that these panels will sit on, in addition to that existing frame rail. For the side panels, I welded on 6-inch sections of steel angle with holes drilled in that will allow those panels to be screwed in from the back. With all the brackets welded in and the whole frame scuffed with red Scotch-Brite, I could finally call the frame fabrication complete and ready for paint. After reading some rave reviews, I decided I would try out Steel-It weldable coating on the frame. It's expensive, but a pretty great product. I expect to iterate on this table in the future at some point, and I want to have a nice coating on it, but I also don't want to have to grind off paint to weld on new brackets, etc. Steel-It has a nice looking satin finish, and you can weld directly through it without prep, which is pretty neat. I used their black color, which is really more of a rich gray, and it complements the cabinets perfectly. I painted the bottom of the frame first before flipping the table over, and then gave it a few more coats once I had it right side up. After waffling between a bunch of options, I ended up using 3/4 inch plywood for the floor and side panels. This is an easily reversible decision if I ever want to try something else in the future, but so far I'm really happy with the outcome. Before coating, I also put a radius on the front edge of the floor panels to avoid the plywood chipping and delaminating when my foot or other things strike that area. After cutting the plywood sheets down to size with a circular saw, I put a few coats of black paint on all sides to seal it. I finished the floors and the back side of the side panels with a few coats of spray-on truck bed liner after that black paint. All of those would be hidden inside the cabinet, but I still wanted them to look decent and hold up to my foot kicking around in there. For the exterior surfaces of the side panels, I really wanted to try out applying laminate myself. I had watched a few videos where people did this for workbench tops, and I figured it would be an attractive, durable way to finish off those panels. There's a wide variety of designs and patterns available for a reasonable cost, and it's an easy DIY to cut and install laminate sheet. I cut the laminate down to be just a little bit larger than the panel that I was applying it to. This gives you some room for error when you lay it down, and once you lay it down, it's down and you can't move it. Later on, it gets trimmed with the router. I'm using contact cement in an aerosol can to glue down the laminate. You can also get this in a quart and brush or roll it on, but I don't need that much adhesive, so I decided to just use the can that I already had around. Spray both surfaces, leave them apart to dry as specified on the can, and then put them together to adhere on contact. The trick that I learned is to use dowels between the two parts to help you align them before making contact. This worked out well, but I'm still glad that I left a good amount of extra on all sides so I didn't have to be super precise with the fit. Once you remove the dowels, you can use a roller to ensure that the two pieces are making good contact so that the glue can bond together. With contact cement, there's an instant bond, so there's no need to wait. You can work with these right away. The next step is to go back and trim the excess laminate. A flush cut bit in a handheld router works great for this, and it's super gratifying to do. This was one of my favorite parts of this project. There are other router bits available that are specifically for trimming laminate like this with different bevels on them, but because this will be recessed into the frame, that edge isn't visible at all and it doesn't really matter. I actually don't want to have a bevel that calls more attention to the edge. I'd rather have it be totally flush and hidden. After routing, there may be some spots to touch up on the paint along the edge, but otherwise these panels are ready to go. Installing the floor panels is just a matter of dropping them into place. I cut the panels to a tight enough tolerance that they don't move around, so there's no need to screw these into place. Additionally, I like the idea of being able to just pop up a floor panel if I ever need to get under it and I don't feel like messing with the caster leveling. This will be great for vacuuming up messes and other things in the future. The side panels push into place from the outside, resting against the brackets. Then they're screwed in from the inside, so no fasteners are visible from the outside. The last big piece to address is installing the two Gladiator cabinets. This is the moment of truth. Everything was designed around them, so if they don't fit, it's going to be a bad day. Tight tolerance again means it's a slow, careful fit to get them in place without scratching paint, but I couldn't be happier with this. I'd rather have a tighter fit and have to be a little bit slower so that I get a much cleaner, polished end look. I was nervous about the laminate I selected matching the frame and cabinets well, but it really ended up being just about perfect. It has a little grain to it which gives more depth than a solid color, and it should hide inevitable dust and imperfections better. Because these cabinets are designed to hang on the wall above you, they have the handles at the bottom, but for this use case that doesn't make a lot of sense. So we're going to go ahead and flip these doors over to get those handles up at the top and make this much more convenient. Thankfully, each door is only held in by 3 screws, so we can go ahead and remove those screws, flip over the door, swap it to the opposite side, and then screw it back in. I'm going to mount the cabinets to the frame around the perimeter of the front face of the cabinet so that once there's weight in there, they don't sag and they stay nice and secure. To do this, first I clamp them into the correct position. Then I drill 4 holes around the perimeter of the cabinet, 1 in each side and 2 in the bottom. I use a drill bit sized to the tap to first drill through the cabinet and the frame, and then I go back with a step bit to enlarge the hole in the cabinet so that the bolt I'm using can clear through that easily. I tap the holes in the frame with a M6 by 1.0 tap, and then finally install socket head cap screws with blue Loctite to prevent loosening over time. With that, the table's complete and ready to use. This was a lot of work, but it was so incredibly worth it. I'm over the moon happy with the end result, and I expect to use this for a long time in my garage. I hope you enjoyed this and you're feeling inspired to build your own table for your garage. Drop a question or comment below and let me know what you think. It's certainly not perfect, but I'm pretty proud of how this idea translated into reality. Subscribe to the channel to follow along with more projects, and as always, thanks for watching. It's now been a couple weeks since I built this, and I've got to say it's really fulfilling the vision I had almost perfectly. It's a great, stable work surface to work on. I'm using it right now to build a wiring harness. I've done some welding on here and it works great for that. And I just love looking at it when I walk into the garage. It does a great job of completing that fabrication area in that corner, and I couldn't be happier.